one else joins before 5 minutes after, I'll go ahead and count them as present. Going to share my screen with you. Do you have any questions or anything I can help you with before we go on with our next topics? Anyone have any questions or anything you want to ask me about? It looks like, and I'm going to go check this out real quick. I'm not going to share my screen this time, but I'm going to go to the syllabus and go to the bottom of the syllabus where we have our course outline. And I think pretty well we're on schedule right now. So today we do 1.6 and 1.7. They kind of go together anyway, complex numbers and quadratic equations. Then Tuesday we will finish with inequalities. And then Thursday, the 9th, we review and we have our first test on the 15th, the following Tuesday. I believe that's right. No, the following Thursday. So we only have one section after today. We do that section. We do 1.6 and 1.7 today. I'm sorry, I'm confusing myself. And then Tuesday we do 1.8. Thursday we review. And then Tuesday the 15th we have our test. So I was just double checking that. You can always go to the syllabus and go to the bottom of the syllabus where I have the course outline with the dates and things on it. All right, so I'm going to try to start sharing my screen here. And 1.6 is complex numbers. So we want to define an imaginary number, define a complex number, and define a conjugate. And then we want to be able to simplify radical expressions that have complex numbers. Making sure everybody can see my screen. Okay. So there are no even roots of negative numbers in the set of real numbers. So in the set of real numbers, there are no even roots of negative numbers. So in other words, you can't take the square root of a negative number or an even root, any even root, the fourth root or whatever. But what we have is a set of numbers called imaginary numbers. And those imaginary numbers, they say were invented, but I don't think you would call it really invented because they do actually exist, even though they're called imaginary, but they do complete the set of numbers. The imaginary numbers are based on a symbol, the square root of -1, and we call it I. So the square root of -1 we call I. So then if you square the square root of -1 and you square I, you get -1 is I squared. And that's where we use I and I squared to work with our imaginary numbers when we have a negative under an even radical. So we say that I squared is -1. Let me look at something real quick. All right, so we say I squared is -1. So I like to write these out. I like to say, all right, so I is the square root of -1. We usually replace any negative under a radical with I. And then when we square that, we get I squared is -1. Then we can write I to the third. I to the third is actually can be broken down as to I squared times I. Well, we know that I squared is -1. So I to the third turns out to simplify as -I. And then I to the fourth, we have I squared times I squared. So that's -1 times -1. So I to the fourth turns out to be our simplest expression, which is just 1. So those are the most common ones that we use. If you're simplifying some number that has an I with an exponent bigger than 4, you can break it down into something that's divisible by 4. We'll go into a few of those a little bit later. So complex numbers have a real part and an imaginary part. So A would be your real part, and then BI here would be your imaginary part because you have the I. So we call those, when there's a binomial there, we call those complex numbers, where you have a real part and an imaginary part. So when you're adding, subtracting, and multiplying numbers that have complex numbers, you can combine the real parts together and you can combine the imaginary parts together. So it's nothing more than just combining like terms. You will end up always combining your imaginary parts and your real parts, but keep in mind you cannot combine imaginary parts with real parts. Just like when you have a radical, you can't add non-radical terms with radical terms. Well, I is just a radical of -1. So you can't combine terms with I with terms that don't have I. You have to only combine like terms. So in this case, we have -1 minus 5I. Then we want to distribute this negative into this parentheses. So that will be -3 plus 2I. Then we could come over here and we could combine the real parts. So we have -1 minus 3. We can put those together. And then we can put -5I plus 2I together. And that gives us -4 plus -3, so minus -3I. So all you're doing is just combining like terms. You will have one of these on your test with a minus there. And I would say about 5 out of every 10 people miss that problem because you'll put -3 and then -2. But that minus in front of that parentheses changes both of those signs. So make sure that you pay attention to your problem. And also don't multiply those, that's subtraction, so it's not multiplication. Okay, this one is multiplication. So we're going to multiply a 3I times 2, and that's going to give us 6I. And then we're going to multiply 3I times I, so that's 3I squared. And we never leave I squared as I squared. We change I squared. I just showed you a couple of minutes ago, I squared is equal to -1. So we always change that to -1 when we have I squared. We leave I alone, but we always change I squared to -1. So 6I minus 3. Okay, this one, you've got to square this. So that's going to be basically -4 squared times I squared. -4 squared is 16. I squared is -1. So this is negative 16. Okay. I do need someone to be responsible for helping me. If somebody has a question, if they're typing in the chat box, what's better for me is if you just unmute, if you have a microphone and you use the mute button up here to unmute yourself and just talk to me. But if somebody doesn't have a microphone and they're typing in the chat box, y'all just watch that and somebody stop me if someone has a question. So I always want you to stop me if I'm going too fast or if you don't understand something and I need to go over that again. Okay, in this one, we have a binomial times a binomial. And so just like any other binomial times a binomial, we would use the distributive property or...
Miss Rachel,
Yes.
someone asked if you wanted to use, someone asked, do you want us to put the imaginary number behind the real number or does it not matter?
Okay, so I guess, yes, I do. I would like for you to put the imaginary number behind the real number. I want you to put it in front of the radical though. So let's say our number is, we have 3 times I. I would like for you to write that, and so would MATLAB, as 3I instead of I3, okay? But if you have the square root of 3 times I want you to put it in front of the radical. Because I3 looks weird. And I guess in a way, I times the square root of 3 looks weird too, but sometimes people will let that I slide under that radical and make it look like the square root of 3I, and that doesn't ever make sense. So that's why we put the I in front of a radical so it doesn't accidentally slide under that radical when we write it. Okay. So I hope that answers. Thank you for stopping me and letting me answer that question, because honestly, unless I click back over, I can't see what anybody is typing. So yeah, thank you. Okay, so now we have the binomial times the binomial. So some people call this the FOIL method, first, outer, inner, last, and some people just look at it as the distributive property. Distribute the 4 to the second 2 terms and distribute the negative 3I. So we're going to multiply 4 times 1, 4. And then 4 times 2I is going to be plus 8I. And then minus negative 3I times 1 is going to give us a negative or minus 3I. And then you're going to have negative 3I times positive 2I is going to be negative 6I squared. Okay, so there's 2 things we need to do here, and I will start shortcutting this a little bit in a few minutes, but for right now, I'm going to just plug in. So I know I'm going to have a 4, 8I minus 3I. Those are like terms, so I can combine those. So that's going to combine me to get negative 5I, 8 minus 3 attached to I. And then the last term is going to turn out to be minus 6, but I squared is negative 1. So again, I'm going to take some shortcuts on this later, but I'm just showing you all the steps right now. So since we've got this turned into a real number now, we can add 4 plus 6, and we get 10 plus 5i. And I really don't care about that, which way you write it. If you write 5i plus 10, that's fine. That may have been what you guys were asking about earlier. So if you were asking about, can you write negative 3i minus 4 right here? That really doesn't matter to me as long as your signs are right. That may have actually been what she was asking about. As long as you've got your signs correct, that's the main thing. And especially if you type it into MathLab, if you type it in, either one of these ways is going to, I think, be fine. You just want to make sure your signs are correct. Okay, these were the ones where I said what I want to do is because I to the fourth is equal to 1, anything that's a multiple of 4 power is going to equal 1. And so I'm going to write this. If I write I to the 4th times I to the 4th times I to the 4th, well, that's I to the 12th. 4 plus 4 plus 4. Everybody agree to that? So that's 1 times 1 times 1. So this one's real helpful if we break down imaginary numbers that have high exponents, because what we want to do is we want to break it down in terms of I to the 4th and then whatever's left over. So I want to think about the next lower number, 35. What's the next lower number that 4 will go into? Well, hope everybody's saying to yourself 32. So I'm going to write I to the 32 times I to the third. And if you don't remember what I to the third is, you can break it down even further. You can break it down into I squared times I. So anything that's a multiple of 4, that's going to be 1. I squared is negative 1. And I is just I. So this whole thing simplifies to negative I. This one, we're just going to write as 1 over I to the 13th because that's a negative exponent. So with a negative exponent, you bring it to the denominator, it becomes positive. Then I to the 13, the next lower number divisible by 4 is I to the 12th. So I to the 12th is 1. This whole thing, anything that's a power of 4 is going to equal, I to that power is going to be 1. So 1 over I. Now, if you remember back where we didn't want to have like a radical in the denominator and we learned how to rationalize the denominator, we've multiplied by that same denominator in the numerator and the denominator. So we got the square root of 2 over 2. Hopefully you remember rationalizing, just doing a little review there. Well, I is also a radical because remember I is equal to the square root of negative 1. So if I want to rationalize, in other words, I don't want an I in the denominator, I'm going to multiply by I divided by I. So that's going to give me I over I squared. Can't write some days. So I over I squared, that's going to give me I over negative 1, which is just negative I. So remember, all I did right here was rationalize the denominator, just like we've learned to do in the past with a radical. It's just I is a little easier to work with than a radical sometimes. So recapping, if you have I to a higher exponent, you want to break it down into an exponent divisible by 4 and then whatever's left over. So I to the 35, I went down until I found a number divisible by 4. That was I to the 32. That left me with I to the third. I broke down I to the third into I squared.
So basically, if you get an answer and it's 1 over I, that's not the lowest you can get it down to. Like, you have to keep simplifying.
Yeah, if you get 1 over I, what that means is that's a radical in the denominator. We just don't write it as radical -1. We write it as I. So that just means you need to rationalize the denominator, which would be this. I would, if I did it with the square root of -1, I would do this, just like I would the square root of 2. We don't write the square root of -1. We write I instead. So that gives us the square root of -1 over -1, which is really I over -1. So it's kind of the same concept as doing this. It's just we don't write square root of -1. We write I. Does that make sense?
Okay. Yes, ma'am. Thank you.
Okay. Okay. So is anybody having any struggles with that? The definition of I and how to break down an exponent? Do I need to do another example like that, or are y'all okay with that?
Another example.
Okay. Gotcha. All right, so I'm going to ask you to try this. So I'm going to give you, you try these. And then I'll work them. I want you to try it first and see if you've got some kind of understanding of it. So I'm going to say I to the, let's do 27. No, let's don't do 27, do 26. Just for something a little different. I to the 26th, and then I to the -7. All right. Hopefully everybody's got these, or at least tried to do these. So I to the 26th. What number lower than 26 is divisible by 4?
24.
Yes. So that means I'm going to have I squared left. 24 plus 2, add exponents, you get 26. So I'm going to have I squared left. Well, this whole thing, since the exponent's divisible by 4, it's automatically going to be 1. And I squared is -1. So that one simplifies to -1. And then this one, I'm going to write 1 over I to the 7th to make that a positive exponent. So then I'm going to break that down into I to the 4th times I to the 3rd. I want to do something because I want to show you how easy this one would be to rationalize if I leave that I to the 3rd. But I'm scared to show it to you that way because I broke it down into I squared times I a while ago. But I want to leave it I to the 3rd right now. Let me just see if y'all understand this. So I to the 4th is 1, right? So that just leaves I to the 3rd. Do y'all see if I multiply the top and the bottom by just I would have I to the 4th in the bottom, and it would just be 1. So to rationalize this one, instead of just multiplying by I to the 3rd times I to the 3rd, it's going to cause me to have extra work to do. How about if I just multiply by I over I? So that's going to give me I in the numerator and I to the 4th. And I to the 4th is just 1. So that's just I. I didn't do that, pick that problem on purpose. But if you think through what you're trying to get to, you're just trying not to have an I in the denominator is all you're trying to do. So the easy way on that one was just to create an I to the 4th in the denominator.
If 1 wasn't on the top, like if it was I to the -7th over something.
So if it was I to the -7 over, tell me what? Just a number or?
Yeah, just a different number.
Like 2? Just
right.
like 2?
Right.
Okay. So you would just start off, so you would really do it the same exact way. You would just bring the I to the 7th down. So you would have 1 over 2 I to the 7th. And the 1/2, it would just stay 1/2. Nothing would ever happen to that 2. It would just be there at the end. So in that case, you would end up with, when you did this, you're going to get the same thing. So you're going to have I, but you have that 2 there. So you would end up just with I over 2.
Wouldn't
the
be
part,
1 over -1, negative I, sorry.
Well, I don't know. Let's just do it and see. So let's just do it. I hope y'all copied that down because I ran out of room. I could have just done another slide, but I'm just going to, let's just do that. So I to the -7 over 2. So the 2 stays there because nothing happens to it. It doesn't have an exponent. So it would be that. All you would do is bring the I to the 7th down. You have to leave a 1 there. So I would still work it the same way. I would keep that 2 there. And I would have I to the 4th times I to the 3rd, which would give me 1 over, this would be 1. So 2 times 1, that would still just be 2. And then I to the 3rd. And you can break that down into I squared and I and do it that way. Or you can just go ahead and do like I did and multiply by I over I. You're going to create an I to the 4th, which is just going to end up being 1 times I is I on the top. And then in the denominator, 2I to the 4th, that's just going to be 1. So you're going to have I over 2.
Okay, thank you.
You're welcome. So anybody can break in like that. And Victoria's watching for me. So if you have a question, just type it in. If you can't just come in on audio like that. Okay, so complex conjugates. Sometimes rationalizing I is pretty easy. So if we have 1 over I, we just saw we can just multiply by I over I, and we get I over I squared in this case. So that's I over -1. So that was negative I. And then we saw one where we had I to the third in the denominator, and we just multiplied by I again to get I to the fourth. Well, sometimes you're going to have things where I don't know if you can remember, because we're going to do a few of these too, but if you remember where you had like maybe 6 minus the square root of 2 as a radical, and we had to use the conjugate to get rid of that radical. Like that, the conjugate just means to change the sign of this middle number, and it creates the perfect squares. So with this one, I've got a binomial in the denominator, so the conjugate of that would be, so 2 plus I has a conjugate of 2 minus I. So to rationalize this I out of the denominator, I have to use the conjugate. So it wants you to write it in this form right here with no i's in the denominator. And that's what our goal is right now, is to get the i's out of the denominator. But like in the previous problem we looked at, we multiplied just by I to get rid of the I. But now we have a binomial term, so we can't do that. So this is where we just use our distributive property. So we've got 16 minus 8I minus 2I. Negative is plus I squared. Now I'm going to come back and simplify that, but right now I'm just going to leave it alone and do the denominator. So I need to distribute here, use the FOIL method. 4 minus 2I plus 2I minus I squared. Now, anytime I have an I squared, I'm going to make that what number? -1, -1. 16, I'm going to combine my like terms in the middle, which are my I terms. So that's going to give me -10I, and then -1. And down here, these two, when I combine those, that's going to give me 0. That should always happen in the denominator, because that's why we're doing what we're doing, is to get rid of those i's. So this would be 4, and then I had a minus -1. So I'm going to combine my terms in the numerator there. 16 minus 1 is 15 minus 10I over 5. And I actually can simplify that some more, because I have a common factor. I can factor out a 5 out of these two, and that's going to leave me with 3 minus 2I over 5. So I can't just divide 15 by 5 and get rid of it that way. I have to factor a 5. The 5 has to come out of both of those terms, and then I can cancel out my 5. So this one would finally end up to be 3 minus 2I. So I write messy a lot of times, but on that one I tried to be very neat and show every single little step there so you could follow what I was doing. So go back over those steps and make sure you understand what I did there. Let me know if you don't. Okay, so I want to look at part B here, and this is just a similar example, but I just don't have a binomial term in the numerator, but I do have one in the denominator. So I've got to multiply by something to get rid of that 6i term, or to get rid of the I. So if I take 5 minus 6i, I can get the conjugate of that. I can write 5 plus 6i. That's what I'm going to multiply by. So then when I distribute in the numerator, I'm going to get 50 plus 30i. Let me show you something back in that other problem before I finish this. Another thing you can do, I just wanted to back up for just a minute. In this one up here, another thing you could do, that's 60. Yes, I see.
Yeah. Your
Show you that.
your microphone.
Huh? Yes.
I don't know what just happened, but we couldn't hear anything you just said. Your microphone like messed up or something.
Okay, what about now?
Yes, we can hear you now.
It may be because I had my hand up there and it was probably over my microphone. I apologize because I was right in the corner. That's probably what it was. But
It's okay.
do y'all see how I factored a 5 out of here up in this problem? You can also do it by just dividing both of those by 5, so you can simplify that way. I just wanted you to know you didn't have to factor to simplify it. You can just separate those two terms. Because honestly, that's how Math Lab's going to want you to put your answer anyway, is they're going to want you to divide those out, whether it simplifies or not. Okay, so now let me correct my error down here. I got my mind off of what I was doing because I wanted to go back and show you that. And if I start muffling again, it may be because of the way I'm writing and I'm putting my hand over the microphone. Okay, so 10 times 5 is 50, and 10 times 6i is 60i. Now in the denominator, I'm going to use the FOIL method or distributive property, whatever you want to call it. So 25 plus 30i minus 30i, and then minus 36i squared. So these two go to 0. So I end up with 50 plus 60i over 25. This I square is going to turn into -1. So I'm going to have minus 36 times -1. That's going to be plus 36. Okay, everybody see that? Now 50 plus 60i over, I believe that's 61. And I think that Math Lab is going to want you to separate those answers and write it like this: 50 over 61 plus 60i over 61. because they want you to write it like this. So they want the they don't want the denominator underneath both, underneath one fraction sign. So they're going to want you to split those up into two fractions so that you have a real part and an imaginary part. Questions on that now? Hopefully I did everything right after that. So keep in mind, if you are going through this class and you get lost for just a minute, you can either stop me and I'll go back, or if I mess up, you can stop me and I have to go back because I have to correct my errors. But there's videos for all these lessons. So if you need to go back over something, go back and pull up the video because they're labeled by lessons. So this would be lesson 1.6 if you wanted to pull up the video. And since all of my slides are labeled with the different sections, you can find the video to match. So we've already established that the square root of -1 is I. So if we have the square root of a negative number, what we do is we can write that as the square root of -1 times the square root of b, and then that -1 just becomes I. So automatically from now on, when I have a negative under the radical, I'm just going to pull it out as I. But this is why you do that, because you're actually just dividing this radical up into a product of these two terms. So square root of -1 times the square root of b, and the square root of -1 becomes I. So automatically, I'm just going to start writing an I right there. So when I simplify these terms, that's the first thing I'm going to do. I'm going to recognize that the square root of 32 is the same thing as the square root of -1 times the square root of 32, but I'm not going to keep writing that square root of -1. I'm just going to go ahead and write I square root of 32 plus I square root of 18. And then remember how to break these down. So we're going to use these to practice on breaking down our radicals. You can break that down into the square root of 16 times the square root of 2. So that would be 4 times the square root of 2. Or you can do a factor tree to break that down. So that's going to be 4, and I'm always going to put the I after the real number, but before the radical. After the rational number, I mean, but before the radical. And then the square root of 18, I can break that down into the square root of 9 times the square root of 2. So that's going to be 3 times the square root of 2. Again, you can use a factor tree. If you're used to using a factor tree, this is what you would do. Break it down into the prime factors. And then any pairs you have, that's a perfect square. So the 3 comes out of the radical and the 2 stays in. So this one now is going to be plus 3I square root of 2. Now, the square root of 2's, those are like terms. Like radicals are the same thing as like terms. So I can combine 4I plus 3I. I can combine the coefficients and then attach it to the square root of 2. So that would be 7I times the square root of 2. And really, we don't do a lot of stuff with this. This is just to help you when we do the quadratic formula when you end up with a negative under the radical. So we don't do a lot of these just simplifying radical problems. But when we do the quadratic formula, a lot of times our answer is going to look like this. So we're going to need to simplify that. So that's really what we're doing here is we're simplifying. So I have -2 plus negative under the radical means that comes out as I. Then I can break down I can break down the square root of 12, to the square root of 4 times the square root of 3. So that's 2 times the square root of 3. So that gives me negative 2 plus 2i. I'm just going to write this, kind of go to the side here. 2i times the square root of 3 over 2. And then we can simplify that. I showed you how we would simplify that by making two fractions. Then we can just divide out the 2's. So I'm going to have negative 1 plus I times the square root of 3. And right here, that's just where I broke down the 12. So hopefully we will practice more of this as we work on the quadratic formula. We'll practice simplifying these radicals more. I won't just do it. I will show you the steps of simplifying them as we go along. So again, there won't be a lot of questions with just plain simplifying radicals. You're going to use that in the next section.
Someone asked where the negative 1
Okay,
comes.
which one? Someone asked what? Say that again. I'm sorry.
I think she meant
Where did
someone asked where the negative 1 comes from. I think she meant in the final answer. It's just negative 2 over 2 and it's simplify.
Yeah,
So
I just divided negative 2 divided by negative 2. I mean, negative 2 divided by 2 is 1, negative 1. Just like this doesn't really cancel out. I mean, we call it canceling, but you're really just dividing and getting 1. So that's the same thing as, so negative 2 divided by 2 is negative 1. A lot of times we get a little bit zealous with our canceling, and we think that when we do 2 over 2 and we cancel, it just goes away. Well, it doesn't. It just leaves a 1. Sometimes we get a little overexcited with our canceling and think that it really just cancels it completely out, but it doesn't. It divides and you get 1. Usually I write the 1 right there, but I forgot. I neglected to do that that time. Okay. So I'm going to skip these for right now. I might come back later and do them, but I don't think you're going to have any like this in Math Lab, and I'm not planning to give you any on the test like this. These are just to practice simplifying radicals. So if you need to practice that, you do that, and maybe next time if I have time, I'll come back and do those. But those are just doing practicing simplifying radicals. So I'm going to skip those for right now and go on to 1.7. And if I have time, I'll go back. I will have time next time, but I want to get through as much of 1.7 as I can because I have a few things I need to talk about in 1.7. We need to recognize standard form of a quadratic. We need to rewrite in standard form if it's not in standard form. And then we've got 4 methods that we need to look at. Now, it should all be reviewed to you. If you took Math 100, this is the last thing that we did in Math 100. If you took this in high school, you should have done this in Algebra 2. So I'm going to take the quadratic equation and make a note here that standard form always has the quadratic equation. This makes it a quadratic equation, x squared. It always is becomes equal to 0 when it's in standard form. So if you have something not equal to 0, it's not in standard form. When you're solving quadratic equations by factoring, what we're using is the 0 factor property. So the first thing we're going to do is we're going to solve by factoring, then we're going to use the square root property, completing the square, and the quadratic formula. Most people don't like completing the square, but some people do. So we're going to go over a few completing the square problems. Hopefully we've done this before. When we did factoring, we would solve by factoring. So hopefully everybody does remember how to factor. So we want to multiply to get negative 18 and add to get negative 7. So we know we're going to have an x times x here. We want the factors of negative 18 that will add to give us negative 7. So that's going to be minus 9 plus 2. If you need help with factoring, please email me and I will send you some videos of factoring techniques. So I'm not supposed to really teach you factoring in this class. And if I do, then I'm using time that I'm supposed to be spending in something else. But if you're weak in factoring, you can't be weak in factoring in this class. So if you're weak in factoring, you email me and tell me that and be honest with me, and I'll send you some stuff that you can use to practice your factoring. I'll send you some videos with lots of factoring examples. Okay. So now the zero factor property says you can set each one of these equal to 0, and you can solve for x. So x equals 9. X equals negative 2. So when we want to solve a quadratic equation, the x squared term tells you that you're probably going to get 2 answers. Sometimes you'll only get 1, but you're probably going to get 2 answers. And one of the methods is factoring. So when we're done, I'm going to list all the methods, and most of the time you can choose the method you want to use. Now this one, this side is factored, but it's not equal to 0. So that causes us a problem. So what we have to do is we have to go ahead and FOIL this side out. So we get y squared plus y minus 12 equals 30. So what I need to do is I need this thing equal to 0. So I need to subtract 30 from both sides. I can't solve by factoring unless it's equal to 0. So that's the first thing we learn about solving by factoring is the quadratic equation has to be equal to 0 before you can solve it. So I'm going to come over here and I have y squared plus y, and that's going to be minus 42. Now it's going to be equal 0 because that's going to give me 0 right there. Now I can factor this. Factors of negative 42 that add to give me 1. So I want to multiply to get negative 42 and add to get positive 1. So that's going to be y plus 7 and y minus 6. Y plus 7 equals 0. This is the 0 factor property here. So subtracting 7, I get y equals negative 7 and y equals 6. Let me re-emphasize, you cannot be shy about telling me that you struggle with factoring, because you're going to use factoring for the rest of this course in different areas. So please don't go from here saying, oh, I don't know if I can factor or not. If you can't factor, I have resources to send to you that will help you factor, but you have to be able to factor. Okay. Don't tell me on here so your classmates can see. Just email me and say, I need some extra help with factoring. I need some resources, and I'll get you some. Now, the two methods where you don't have to have your quadratic equal to 0 are the square root property and completing the square. And because the reason you don't have to is because you're taking the square root of both sides of an equation to solve. So when you use the square root property, and this is easy if you've just got x squared and a constant, because then you can just take the square root of both sides and you're done. So like with this one, I can't factor it because it's not a perfect, this is not a difference of squares. It's also doesn't have a middle term, so I can't factor that one. So my options will be use the quadratic formula or use the square root property. So the easiest way is just to add 8 to both sides, thinking that I'm going to use the square root property, probably. So I'm going to get x squared equals 8. The only thing is when I take the square root of x squared, what that means is I'm going to get a positive and a negative answer over here on the right. So if you solve using, y'all listen to me and really pay attention to this. If you're really listening to me, don't make this mistake because you're going to miss half of your points on a problem if you only give me one answer. This has two answers. It has positive square root of 8 and negative square root of 8. So x is positive square root of 8, negative square root of 8. And then I can simplify the square root of 8 by breaking it down into the square root of 4 times the square root of 2. So that's 2 times the square root of 2. So the answer is positive 2 square root of 2, negative 2 square root of 2. And I'm just telling you, you lose a lot of points by just doing careless things. When you use the square root property, go back and look at your square root property. You always are going to have a positive and negative answer for that. On B here, you could FOIL this out and work it out by trying to factor it or using the quadratic formula. But see, this is a perfect square. This is also a perfect square. So I can move the 16 over to the other side, and I'm going to get x minus 3 quantity squared equals negative 16. I can take the square root of both sides and I get two equations. One of them, just put a plus or minus right here when you do that, plus or minus. I'm going to get x minus 3 because the square root canceled the square equals plus or minus. Now that's a perfect square, but I have a negative there, so that's going to give me 4i. You can't leave your answer like that. So here's what you need to do. Write your two equations. You have two equations there. It just doesn't look like it. Write your two equations. X minus 3 equals positive 4i. And x minus 3 equals negative 4i. That's what that says, positive or negative 4i. And then add 3 to both sides of your equation. X equals 3 plus 4i or 4i plus 3, I don't care. And add 3 to both sides here. X equals 3 minus 4i or negative 4i plus 3. I don't care about that either. Either order. You just can't leave your answer like this. You have to go ahead and solve for x. So you got to write your two equations and solve it for x. So that's the square root property, and A is the easier case, B is the one that's a little bit harder.
What did you do after? I'm kind of confused. Like, you got x minus 3 squared equals negative 16. Then what did you do?
I took the square root of both sides because that's my whole goal, is to solve that equation for x. So just like up here, look at the first problem. I had x squared equals 8. I took the square root of x squared. I got x.
Mm-hmm.
Okay, well here I had x minus 3 quantity squared. It's a perfect square. So you can solve a perfect square equation by taking the square root of both sides. So that's what I did in both cases. I took the square root of both sides here. I took the square root of both sides there.
Oh, okay. I got you. Thank you.
Okay. So that's what I'm trying to do, is just get rid of that square. And the whole goal of the whole problem is to figure out a way to solve that equation for x. So there's like 4 different ways you can do it: factoring, square root property, completing the square, quadratic formula. All of those ways you can use to solve a quadratic. Some people like the quadratic formula and would rather just use it all the time. That's up to you. Now, on the test, it might ask you questions about completing the square or something, so you need to know how to do it. But if it's just saying solve, then you can use any method you want. So now the third method, so we've gone through 2 methods, so 4 methods to solve quadratic equations. And if we don't finish this lesson today, we've already done like 1.6 and a lot of 1.7. So if we have to, we might have to come back and do the rest of 1.7 next week. And if we do, we can do both of them because it's not going to take me the whole time to go through 1.8. So it's only going to take me just really a little while to do 1.8. So if I need to, I'll move the due date for 1.7 to be due with 1.8, because I'm not going to try to rush through this. So if I only get through completing the square today, we'll do the quadratic formula on Tuesday, and I'll just move your due date because 1.8 is kind of short. Okay, so the goal of completing the square is to get a perfect square trinomial on one side. And a perfect square trinomial factors into a binomial squared, like B in this example, like example B. So that's what we're trying to get our equation to look like. So here are the things you need to consider with completing the square. If the x squared is, if the coefficient in front of x squared is not 1, we're going to make it 1. We're going to divide everything in the equation by that number. Then we're going to complete the square by adding b over 2 squared. So this is just a little table of the steps so you can kind of follow through. Then you're going to factor the perfect square trinomial and use the square root property and simplify any radicals. So that's what I'm going to do. I'm going to follow those steps. So if you need to go back and look at those steps, that's the steps I'm about to take. Now, I can, let me just write this. So the first step is to see if x squared is, if it has a coefficient other than 1. So in our example, no, it doesn't. That's 1. So I'm going to check x squared and make sure the coefficient's 1. The second thing I'm going to do is move all constants to the right. The constants are the ones that do not have a variable. So I would actually, on this one, I always put that as my step 2. So let's just put it up here with step 1. Move constants to the right. So we checked our x squared. It's 1. We don't have to divide by anything. Now moving all constants to the right. That's what I'm doing now. My constant is 9. So I'm going to subtract 9 from both sides. I'm going to leave a space right here because I need to complete the square. So the whole point of this is to make a perfect square trinomial that I can factor into a binomial square. All right, now usually I like to do this so I don't forget. I'm going to make a square right there. So that's what I'm literally doing, is completing the square. I think I did this on the circles too. So completing the square means I take this 8, divide it by 2, and square it. That's what that means in that step where it says b over 2 squared. B is the term that's next to x. A is always the term next to, what on earth? Where did that come from? Okay, so 8 over 2 is 4 squared is 16. So I'm adding 16 to both sides. Now I can factor this into x plus 4, x plus 4, because I can multiply to get 16 and add to get 8. And then on the right, that's going to give me 7. Now I can write my binomial squared. Now this ought to look familiar because now I have a perfect square on the left. I can take the square root of both sides and solve. So now I'm using the square root property. So square root of this side equals positive or negative square root of the right. I'm going to come over here and finish. So that's going to give me the square root here, leaves me with just x plus 4 equals positive 7, positive square root of 7, or negative square root of 7. So I end up with x plus 4 equals positive or negative square root of, and I come up here and write my 2 equations. So now I have to solve from here. My equations should say x equal when I'm done. Doesn't matter to me which way you write it. You can write negative 4 plus square root of 7, negative 4 minus square, doesn't matter. I usually write it one way one time and another way another time, just to show you I don't care and it doesn't matter which way you write it. So completing the square, the whole goal is to get it to where you can use the square root property to finish the problem. So you're literally completing a square here to make this a perfect square binomial, a perfect square trinomial that can factor into a perfect binomial squared. Okay. So how about if we do one more? I'm going to put a new slide in and I'll do the second problem there. All right, so the first thing I'm going to do, remember, is move my constant to the right. Then I'm going to check my x squared, and that's not 1. So since that's not 1, that means I need to go through here and divide everything in that equation by 2. So these cancel out to 1, so that gives me x squared minus 2x. I'm going to leave a space here for completing the square. Whatever I add to the left, I have to add to the right, or I've changed my equation. Go back to your steps. Here's your steps. You got to learn them, but here they are for right now. You can look back at them. So move constant to the right. I divided. You can do these in either order. It doesn't matter which one you do. You can divide first, or you can move the constants to the right first. It doesn't matter which one you do first. What matters is next you want to add the b over 2 to both sides of the equation. So that's what I'm about to do now. So the b is the x is next to the x term. Remember standard form. Ax squared plus bx plus c equals 0. That's the b. A is always the next to the x squared term. Ax squared plus bx plus c. So b over 2 squared is negative 2 over 2 squared, which is negative 1 squared. It's 1. So I'm going to add 1 to both sides. I'm going to factor this. Factor, I want to multiply to get positive 1, but add to get negative 2. So that's going to be negative 1, negative 1. Common denominator, this is 3 over 2. And do that on your calculator. So x minus 1 squared equals 3 over 2. You're going to square root both sides. So I'm going to square root both sides. Remember to put your plus or minus here. And then basically we have to just write our two equations and solve for there. So I have x minus 1 equals positive, and I would have to fix that radical. I'll do it next time. X minus 1 equals negative square root of 3 over 2. So we've got to rationalize that denominator and all that, but I'll do that next time. Just keep in mind you're doing the square root property, so you're going to have a positive and negative, so you can write your two equations and solve. So you can see next we have the quadratic formula. If you want to pick up here yourself and try to finish solving for that, but that's where I'll pick up next time when we come back. So I'm going to move your 3.7 assignment to be due the same day. I mean, the 1.7 assignment to be due the same day as the 1.8, so we can finish this one Tuesday. Fair enough? Y'all have a good long weekend, okay? And if anybody wants to stay and